What's up, guys? It's Mr. Bringle, and today we're going to be going through the energy math examples. So in a previous video, I've already gone through the very top of this page that has the variables and units and equations that we will be using. It looks like this. So if you haven't watched that video, go ahead and give that a quick watch, and then come back and we'll talk about these example problems. Let's go ahead and jump into it here. So the first problem says that Betty has a mass of 15 kilograms and a velocity of 25 meters per second. What is her kinetic energy? So that's a little bit too far there. Let's zoom back out. So let's start by writing out our givens, right? So we'll start with our G step here. And this has told us that Betty has a mass of 15 kilograms. And it says that she also has a velocity of 25 meters per second. And then we know that we're solving for the kinetic energy of Betty. Okay, now the next step is to write out the units for the unknown. And so I always want you guys to rewrite the unknown. Kinetic energy is what we're solving for. And then these are new units. We now know that kinetic and potential energy are both measured in joules, which is a capital J for the symbol. Okay, let's move on to the equation here. Since we are solving for kinetic energy, we can simply use the very first equation on your sheet. Kinetic energy is equal to 1/2 times mass times velocity squared. And just remember that we're only squaring the velocity. So it might make more sense if you put this in parentheses here so that you don't accidentally square the mass as well. So let's go ahead and substitute in our values here, our knowns. So kinetic energy is equal to, we're going to multiply 1/2 times the mass, which is 15 kilograms, times the velocity squared, which would be 25 meters per second. And then just that number is squared, the 25. All right. And so what I would suggest that you do to get your answer here is I would suggest that you type in 25 squared. So there should be a button on your calculator that will allow you to square a value, or you can just do 25 times 25. That will give you the squared value for 25, which is 625. Then multiply that by 15, which is 9,375, and then divide it by 2, and you'll get your answer of 4,687.5. And then, of course, the units there are joules. Okay, so there's our first problem there, solving for kinetic energy. Let's move on to our second problem. It says that Bubba has a mass of 250 kilograms. Should have done this on the last problem, but let's underline here. And 540 joules of energy. Okay. And then it says, how fast is he moving? So notice that it does not say specifically what type of energy here, but it does say how fast is he moving. Okay, so we do know that we are going to solve for velocity here, and that this is a value of kinetic energy right here because Bubba is moving. So let's go ahead and write out our givens here. Bubba has a mass of 250 kilograms. He has a kinetic energy value of 540 joules. And then we are solving for how fast he is moving, or the velocity of Bubba. And when we go ahead and rewrite that, and we'll put in the units here that we're going to be solving for, and we know that the units for velocity are meters per second. If you forget, they are at the top of the page. Now, the equation here, since we are solving for velocity, this is a little bit more complicated of an equation, but velocity is equal to the square root of 2 times the kinetic energy divided by the mass. Okay. So we'll go ahead and substitute our values in here. And the velocity of Bubba is going to be equal to, well, there's three lines there. The square root of 2 times 540 joules. Okay, so this is in parentheses here. Divided by his mass, which is 250 kilograms. Okay, so you may or may not have dealt with square roots before. What I would like you to do here is I would like you to go ahead and multiply. Don't try to put it all in as one equation. Just do 2 times 540. You should get 1,080. Divide that by 250. You should get 4.32. And then use the square root button. And then there should be a button that allows you to just insert your previous answer. If you're not sure how to do that, I'll show you in class. Or you can just do square root of 4.32. And you should get 2.08 when we round, 2.08 meters per second. Okay. All right. So we can now go ahead and move on here to our third problem with Whiskers the cat. Okay. So it says that Whiskers the 5 kilogram cat, so it's given us the mass right there, is at the top of a 10 meter high tree. So that's going to be the height that the cat is above the ground. And then it says, what is the potential energy? So we'll go ahead and write out our givens here. It told us that the mass of Whiskers is 5 kilograms. It also told us that he is 10 meters above the ground, so his height is 10 meters. And then we are solving for his gravitational potential energy. We know that potential energy is measured in our new unit here of joules, capital J. Okay. We'll go ahead and write out our equation. Potential energy, specifically gravitational potential energy, is measured by multiplying the mass times the acceleration due to gravity times the height. Well, we kind of need to go back and add in one more known here. Even though the problem didn't specifically tell us, we also know that the gravitational potential energy on Earth is always, for our class, 10 meters per second squared. So we can add that in there too, because when we look at that equation, we're like, oh shoot, we don't have G written down for in our givens. Let's go ahead and get that in there. Okay. So now we substitute the values in. Potential energy is equal to the mass of Whiskers, 5 kilograms, times the acceleration due to gravity on Earth, which is always 10 meters per second squared. So you won't be given that in the problem. It's something that you'll need to know. And then times the height of Whiskers, which is 10 meters. Okay. And so then when we solve here for potential energy, you're going to do 5 times 10 times 10, and you are going to get 500 joules of potential energy. Okay. All right, now moving on to our last problem here. Spot the dog. We've got really creative names here. So Spot the dog, he's 18 kilograms. Okay, so there's our mass. He's at the top of a ladder, and he has 882 joules of potential energy. And then it says, how tall is the ladder? So we're going to be solving for the height here. So in our givens, it does tell us the mass of Spot. He's 18 kilograms. It tells us that he has a potential energy value of 882 joules. Since we're talking about potential energy, we know that we're going to be using gravitational or the acceleration due to gravity, which is always 10 meters per second squared. And then it says how tall is the ladder that he's on, so we know that we're solving for the height. So height is a distance measurement, so that is going to be measured in meters. And then we can go ahead and write in our equation here. Okay, so the height of an object is equal to the potential energy of the object divided by the mass times the acceleration due to gravity. So when we substitute our values in here, we're going to go ahead and plug in 882 joules divided by, and then down here it's going to be 18 kilograms times 10 meters per second squared. Okay, so if you put this in all at once, you need to make sure to put that 18 times 10 in parentheses in the bottom. So if you type it in your calculator and do 882 divided by, you need to start a parentheses, do 18 times 10, and then end the parentheses. And this will give you 4.9 meters. Okay. So that concludes the example problems for our energy math. You now have practice problems that you will do on your own. Please let me know if you have any questions.